Hello guys, can you hear me? Please let me know in the chats if you can hear me. Okay, I'm seeing myself in the screen. Ah, it seems again we have some delay. Can someone verify that you hear me? You couldn't? Do you hear me now? Okay, awesome. Finally. Finally. Okay, so I think that we should wait a little bit more for the others to join because there are only right now there are not a lot of people here. So let's wait for 1 or 2 minutes. So how was the contest? Problem F. Yeah. Problem F. I did it also in OAF and to the fourth. So it was mostly greedy, not dynamic programming. It was mostly greedy. A, B, C, E. Also, I also solved the first 6 problems. A, B, C, D, E, F. But didn't have enough time to work on the last one. G. Yes, I also did it with linked lists. So maybe it was some issue in your implementation because I also used linked list. Yeah, exactly. You have to use map additional to the list. Okay, I think now is a good time to start. I think most people have joined so far, and we can start discussing the problems. Okay, let's start with with problem A. Problem A is a very simple problem. Let me also show you my submissions. It just tells you that you are given a string S consisting of lowercase English letters and these bars, and S guaranteed to contain exactly 2 bars. Remove the characters between 2 bars, including the bars themselves, and print the resulting string. Well, it's a very simple problem. You should remove everything in here. Well, what I did was that I was thinking that I had a boolean that initially is false. Whenever I see the first one, I make it true, and the first bar I make it true, and whenever I see the second bar, again I set it false. And whenever this boolean is false, I will see out that corresponding character. So let me show you my code. I have some boolean fl which is equally false. This is a flag that means that am I between these two bars or not. Initially it is false. Whenever I come to a new character, if it was a bar, I just say that fl xor equal to 1. So I change the status of fl, and then if fl was 0, I see out si. So it will remove these two bars. It will print all the characters except two bars and everything in between them. So is this one okay, or you need more explanation? Shall we skip to the next problem or talk more about this one? Ideally, I do not know how is it possible. Did you solve? The only reason that we use map in this problem is that we want to, if you're talking about problem E, in problem E, because numbers can be too large, we use map. Actually, a little bit hard to implement, took 6 minutes. Well, in this case, it's not hard to implement, right? I mean, this way, it is very easy. You just have a flag and you just change the status of the flag and we will go forward. F is not extra. No. Okay, so let's move on to the next problem. Let's move on to problem B. Well, this problem says that you have an array. It contains n integers, a1, a2, to an, one per line and over n lines. And n is not given in the input. And whenever you know that the last element is 0. So whenever you reach 0, you are sure that you reached the end of your array. And at the end, you have to write the array in the reversed order. Well, what we can do for this? This problem is also simple. We start inputting all the elements. Whenever we reach 0, we break. We have a while and we see in all the elements one by one. Whenever we reach 0, we break. And at the end, and we push back all the elements in a vector and we reverse this vector and see out it. So this code is also very simple and very short. While seeing x, wake.pushback x, if x was 0, break. And then reverse your vector and see out all the elements. Is it okay? Shall we skip to the next problem, or do you want me to talk more about this problem? Also, if not x is unnecessary, yes, you can say that, because your input is from a file, then we can just even remove this and that would work. Yeah, that's a great point. But because I was testing on my own computer, and in your own computer, it doesn't stop if you don't use this break. And I didn't want to use files, I just said that if not x, break. We can also do sin x and x not equal to 0. Well, the only issue there is that this way you will not push back the last 0, right? So if you do that in here in the first line, after your while, you should say that work.pushback 0. Yeah. Yes, we can see out 0 or push back to vector manually. Yeah, exactly. Can you say reason of what? If in here we say that sin x and x was equal to 0, then we will not push back the last 0, right? So we have to push back that the last 0 manually, or see out it manually. Okay, so we'll close this. I keep closing this because there's a Interesting fact, I slept for 2 hours before the contest, and it was so hard to wake up at the morning until around 4:30, 4:40. I was just recording and editing a video about prefix sums, and I uploaded it. I edited it and rendered it and uploaded it and posted a CF log. And then after 2 hours, I had to wake up and participate in the contest. It was so hard, but I enjoy doing this, so that's what makes it easier. Yeah, thank you for supporting me. Thank you very much. Okay, let's move on to the next problem. In the next problem, you are given three sequences: A1 to AN, B1 to BM, and C1 to CL. Additionally, a sequence x1 to xq is given for each I from 1 to q. Solve the following problem. Is it possible to select one element from each of A, B, and C so that their sum is xi? Well, when I encounter a problem like this, the first thing I see is these limits. I see that n, m, and l are at most 100, and that's very useful. You know, when n, m, and c are all up to 100, I can have a for on all of them. I have iterated over any tuple I from A, j from B, and l from C, and then see that what is the sum of these three numbers, and just mark the sum of these numbers that yes, I can make this number. Indeed, I can make this number. Okay, and then only I receive all the queries and I see out if the mark was true. I see out yes, otherwise I see out no. So if I show you my code, it's something like this. I see in all the values for the three arrays, and then I have a for on 3 indices of these three arrays, and I say that mark of A of I1 plus B of I2 plus C of I3 is true. I mark that. I say that, okay, I can make this number. I can make A of A1 plus B of I2 plus C of I3. And then I see in all the queries, and after that, if mark of X was true, I see out yes, otherwise I see out no. Is this solution okay as well? So I just iterate over all three numbers, possible numbers, all three iterations. I iterate over all three arrays, and I mark the sum of these three numbers, and I see that if using that and I say that mark of the sum of these three numbers is true, and at the end I see that this x that is given, if its mark is true or not. Okay, so if you want, we can make it faster, no problem. Just stop me whenever you want. Yeah, this is not case sensitive, so that's okay. You initially have a problem. You initially have an empty string s, and you have n bags. The bag number I contains some number ai, and it contains ai different strings, and you will repeat these steps each time you do one of these two actions. You pay 1 yen and select one of the strings from bag number I and concatenate that to the end of a string s, or do nothing, skip this bag. Okay, so given a string t, you need to find the minimum amounts of money required to make the final s equal to t. So we want to choose a subset of bags, and from each of these bags choose one of their strings, so that if we append all these strings after each other, we will have our string t. Well, I can simply use dp to solve this problem. In here I can just say that let's have some dp of n and n, which means that if I processed all the bags until bag number I, and I have covered the first j letters of t. So I have some bags, right? I have some bags and I have this string t. I means that I have covered, I have processed the first I bags, and after that I have covered the first j letter of t, j letters of t. What is the minimum cost to do that? What is the minimum cost that if we only had the first I bags, we had to cover the first j letters of t? I calculate this cost. Okay, so this is the definition of my dp. Now, when I want to calculate this dp, as you can see in here, I have a for from I is from 0 to n minus 1 because I want to update I plus 1. Initially, only dp of 0 and 0 is 0, and then my second for is j from 0 to size of t, size of big T. And I have which shows that how many letters I have covered. And I have another for to see that, okay, which one of the strings I want to choose. Which one of the strings that I have, I want to choose to append at the end of my string s. And after I chose that string, I have a CNT to find, I know that I have covered t so far till character j. And I know that what is the next string that I want to append. So I just have a CNT and I will move CNT forward until the next letter of s, the next letter of this string and t are the same. Until they are the same, I will move forward. And at the end, if CNT was less than size of this string, it means that this string does not completely fit into T. If the CNT didn't become equal to this size, it means that it did not completely fit into our string. So we cannot use that. We cannot use this one. Okay. So in this case, we shall continue. Otherwise, dp of I plus 1 and j plus CNT, because CNT is now equal to the size of this string, and we know that it completely matches with T. CNT of j plus CNT, because we append this one, and this is CNT letter, CNT of dp of I plus 1 and CNT plus j is equal to minimum of its current value, and dp of I and j plus 1. This is the case that I append this new string at the end of it. So I consider this case. And I say that dp of I plus 1 and j plus CNT is equal to minimum of itself and its new value. And by doing this, we will find the answer. And then at the end, I just say that dp of I plus 1 and j is also equal to minimum of itself and dp of I and j, because there is also a possibility to skip this back, right? And at the end, it's just enough to say that cout dp of n and size of t. And if this dp was greater than n, we know that the answer is at most n. The answer can be at most n. So if it is greater than n, it means that there are no bits. Initially we set it equal to inf, and it is still inf. So we should just cout minus 1. Is that okay? Can you please re-explain using your 3-step breakdown of DP problems method? Yeah, sure. The breakdown that I told you in the DP playlist, I said that the first one is the definition. We define the essays of DP. Then we find the base cases. And then, after that, we will find out how to update the values of DPs. And then, we see that what is our final answer using this DP. So in here, the definition of my DP is that if I only have bags 1 to I, and I only want to cover T of 1 to J, so I only have these bags, and I only want to cover these letters. What is the answer? So definition is this. So my definition is this. The base case is DP of 0 and 0, which is 0. Okay, the base case is DP of 0 and 0, which is 0. And the way that I update is this. Each time from the next bag, I choose one of the strings, and I say that, okay, I append this one to the end of my current prefix. So I see that if this new string completely matches with T, if this C and T will be equal to size of S, I, and L, I just say that, okay, then I can append it after the current string that I have. So dp of I plus 1 and j plus c and t, because the length of this new one is c and t, and j plus c and t is equal to minimum of its current value and dp of I and j plus 1. And then I just say that also dp of I plus 1 and j is equal to minimum of dp of I plus 1 and j and dp of I and j, because it was also possible to just skip this back. So this is the way I update. And my final answer is dp of n and size of t. So all the 4 steps are done. And this way we can solve the problem. What's size of Si and L? Well, Si and L is the string that we choose to append to the end of what we have already. So we are on bag number I, and we have chose the string number L from bag number I. So S of I and L means that bag number I, the string number L. Okay, so this is bag number I, the string number L of that bag. And we say that while j plus c and t was less than size of t, because we should compare t of j plus c and t and s of I and L and c and t. Okay. While c and t was less than size of s of I and L, and t of j plus c and t was equal to s of I and L and c and t, I say c and t plus plus. And after that, I just can say that if c and t was less than size of I and L, it means that it did not completely match. It means that this new string did not completely match with t, so we cannot append it. If we append it, there would be some mismatches. Okay, so if that happened, it means that there are some mismatches, and these two did not completely match. And then if it matched, we just say that dp of I plus 1 and j plus c and t is equal to minimum of dp of I plus 1 and j plus c and t and dp of I and j plus 1. If it could match. And then dp of I plus 1 and j is equal to minimum of dp of I plus 1 and j and dp of I and j. Does this make sense? Why we getting trial A using recursion? It depends, because if you do recursion, it's important that you will memorize the values so that you don't compute them again and again, over and over again, because doing that would make your time complexity exponential. Okay, so that way you need to make sure that what you have to make sure that you will memorize each answer that you calculated, so that you avoid calculating once again. Is this problem okay? Shall we move on to the next one, or do you still have questions about this one? I was doing 2 cases, take something and not take something, and after each checking if it is a starting of given a string or not. Yeah, when you consider these 2 cases, you have a states, and you consider these 2 cases for that state. Well, the point is, when you do that, you should just save that, okay, what was the result of your calculation? After you calculated it, after you found the answer, you should save that what was the result of this calculation. so that the next time that you came back to this state again, you will not again branch into two cases and calculate them again from the beginning. So the main point is that you save that what was the value before. So for example, you have some state, you say that okay, I will, when I have these states, I will branch it into two states. Well, the next time that you come to this state, you should not again branch it into two states, because you are calculating the same thing over and over again. The first time that you calculated that, you save that so that the next time you can simply return the value that you saved. There was a problem with CF in which used iterative DP and got TLE, but recursion got accept. It depends. It depends. Most of the time, calling functions have an additional time, and not using them is better. But in that specific problem, maybe there was also another factors that impacted the time complexity. Okay, awesome. Are there any other questions? Feel free to ask your questions if you had any question. Can we solve it by combining all string into one array and apply DP? You mean combining all the strings of the same bag into one string? You mean combining the strings of the same bag? If you mean that, we should not do that, because we have so many strings and we should just choose one of them, not all of them all together. So we should just choose one of them. So we should not combine them. Yeah. Yeah, awesome. Are there any other questions, or shall we skip to the next problem? Can it be done? Can it be done using knapsack? Well, it is some sort of like knapsack. You know, it is kind of like knapsack. If you see, you know, this two-dimensional DP completely looks like knapsack. Each time we are thinking about adding this CNT or not adding it, but it's some knapsack with different choices. Maybe we can choose to add a string of length 2, or a string of length 3, or a string of length 10. So it's some sort of like knapsack, this two-dimensional DP. So we are assuming that should we add this CNT in this step or not. So we just have a group of different numbers, and some of them can match with the current string that we have, and some of them cannot. Some of them get removed, and the rest of them we should choose either one of them, or we do not choose any of them. So we consider all these cases and calculate minimum. That is some sort of looks like knapsack. So that's the same philosophy, kind of, you know. We are kind of doing the same thing. Any other questions? Okay, I think we should move on to the next problem. Well, the next problem is problem E. But I'm bad again. Oh, right. Okay. So you should train deeply more. If you want, I will tell you some problems that you can solve to make that better. I will send it to you or in our Discord server. Okay, the next problem: insert or erase. You are given a sequence A equal to A1 to AN of length n. I'm teaching DP. I already have a DP playlist. Have you checked that out? Okay, I read the problem statement and then I answer the comments. you are given a sequence A equal to A1 to AN of length and the elements of A are distinct. Process queries in the order they are given. Each query is one of the following two types. One, X, Y, insert Y immediately after the element X in A. It is guaranteed that X exists in A when this query is given. And 2x means that remove the element X. And it is guaranteed that after processing each query, A will not be empty and its elements will be distinct. Print A after all the queries. Well, in this problem, as you said before, yeah. Okay. As you discussed it before in the chats, yes, this problem is linked list. We can just, this is very classic. This problem was very classic, and I was just saying that way it is so simple. Because I guess that the previous problem D, for example, was harder than problem E. But anyways, in this problem we can just use a linked list and just implement both of these queries, types of queries, using a linked list. So in here we can say that whenever we first we make a linked list, we just keep that for each element we keep that what is the next element of it and what is the previous element of it. So we start initially, we set our, we have an imaginary number -1 to the left of our string. It's always better to have something like this in our linked list. Most of times it makes your implementation easier. Okay, so we have this linked list, and initially we have an imaginary number -1, and we start from 0 to n, and each time we see in X, and we say that next of the last element that we had is X, and previous of X is last, and then we set last equal to X. So this is basically just making the linked list. And at the end I add another imaginary -1 as well. I said that next of last is equal to -1, and PRV of -1 is last. And we have defined it as map, so we can use any integer instead. We can also use -1 instead. And then we see in all the queries, and first we see in the type of them. If the type was 1, we see in X and Y, and then we say that first we want to add X in here. So we say that next of this Y should be next of what X was. The next of what was the next of X. So you have this X in here and next of X in here. The next element of X in here. And what you want to do is to add Y in the middle of them. You want to add Y in the middle of them. So the next of Y should become next of X. The next of Y should become next of X. And the PRV of next of X should become Y. And then next of X should become Y, and PRV of Y should become X. This way we can simply update our linked list. That's maybe you can assume that it's like a cyclic connection, but we can also assume that there are two different -1s. So it's not always it's not, if you want to see it as a cyclic connection, but it is not intended to be a cyclic connection. So you can also assume that there are two different -1s. Yeah. Why do you do not? I was more comfortable just have a map and just points out to the next and the previous elements. I thought that that was simpler for me. And okay, so simply we can do this. Simply we can find these values, and then I have this query that removes some elements. When we want to remove some element, this is x, this is PRV of x, and this is NXC of x, next of x. This is the previous element and this is the next element. We can just say that next of PRV is next and PRV of next is PRV. So this simple x will be removed. And then at the end I start from -1 and I say that while x equal to next of x was not -1, see out x. So each time I say that x is equal to next of x, and then I compare the resulting value. I compare the resulting value of x with -1. If it was not -1, it means that the array is not done yet. It's not over yet. So we see out x, and at the end we just see out n1. So does this one make sense as well? Do you have any questions about this one, or shall we move on to the next problem? Oh, we have a lot of delay, unfortunately. So maybe it's better if I open the next problem in the meantime. I'm seeing myself that I'm far behind. Okay, so I will start talking about the next problem as well, and I will also check the chats, and if you ask any questions, I will answer that. This problem says that there is a grid with n rows and n columns. Let I and j denote the square at the ith row from the top and jth column from the left. And Takashi is initially at a square 1 and 1 with 0 money. Each time he can do one of these three actions. He can do one of them. Stay at the same square and increase his money by P of I and j. Or pay R of I and j from his money and move to square I and j plus 1. Or pay D of j from his money and move to square I plus 1 and j. So he can do one of these three things. And he cannot make a move that would make his money negative or take him outside of the grid. If Takashi acts optimally, how many actions does he need to reach square n and n? Well, this problem, I solved this problem greedily. Well, the main point in here is that for each cell, if, for example, you are at some cell and in the path to this cell you had another cell, for example, assume that P of I and j for this cell is x, but before this cell there was another cell such that P of I and j for that cell was less than x, greater than x. Then I will be sure that I will not stay at this cell. I will not stay at this cell because if I wanted to stay more, I could stay more. I mean, if I'm gonna stay for 1 second in here, instead of that, I could spend 1 second in here and save that additional money and spend it here. So it doesn't make sense to stay here. So if you have seen another one, if you have seen another element before, another cell before, that it is greater than your current element, it is not optimal to stay at this element. Does this make sense? So that's the first important thing. And then I say that, okay, so then I have to just choose some subset of cells, which are the cells that I will stop at them. This subset of cells is are the cells that I will stay at them. And I can just be sure that in between I will just move. I will not stay at anywhere. So P of I and J for these ones does not matter. We just need to calculate the distances between each two consecutive ones. And for distances, we only care about the values of R and D. We do not care about the value of P of I and J anymore. So we just calculate what is the distances between each two cells. And we do that using dp. In here you can see that we can just simply say that this stuff I and I1 and J1 and I2 plus 1 and J2 is equal to minimum of itself and distance of I1, J1, I2, J2 plus d of I2 and J2. Okay, so this is what we can say. It is distance of I1 and J1 and I2 and J2 plus d of I2 and J2, because I say that, okay, I move downward with this. And the same thing is the same possibilities that we will go rightward before reaching there. So we just consider these two different cases and we calculate the distances between each two cells. And then when we have the distances between each two cells, each two of them, you know, the main point was that we will not stop at these ones. So only R and D matters in between. And we just need to find out these distances. After that, when we found out these distances, we can just say that we will have a dp on all these cells that we want to stop on them. Assume that the previous cell that we stopped on was this one and the next one is this one. The next cell that I want to stop is this one. The point is that I can say that greedily it is always to be at a cell. If there are several ways to reach here, it's always the best to reach here by using the minimum number of operations first. That's the first priority. Always the first priority is that I reach here with the minimum number of operations. And the second priority is that the remaining money when I reach here is maximized. So there are two things that I will keep. Best of some cell means that how many steps does it take to reach there, minimum case scenario. And rem of I2 and J and rem of each cell means that what is the remaining money that I have when I reach there. So ask me questions if in any parts you were not sure about what I'm saying. So feel free to ask questions if any part was not clear. So this is how it works. Okay, this is how I say that greedily is first best to be there in the minimum number of operations and then have the maximum remaining money. Why? Because if there is another way that we reach here with more operations, with more time, but we have more money, well, the point is all the cells that we have seen so far, their value of P was less than the value of P of this new cell. The value of P of all the previous cells is less than the value P of this new cell. So it always makes sense that instead of staying in the previous cells, I say that, okay, I come here with minimum number of steps and then I will stay here instead. Then I will have more money. So the greedy makes sense here because we can say that this one has more value of P of I and J compared to the previous ones. So it makes sense to reach here as soon as possible. And then when we reached here, we can just say that we can stay in here as much as we can, as much as we want. So if we could, instead of wasting our time in the previous cells, we spend that time in here. So this is basically the idea of this greedy. It's always the best to minimize this pair, the minimum number of operations, and minus the remaining money that you have. Why minus? Because we want to maximize the money. We want to maximize the remaining money. So we want to minimize the minus amount of money. So if we negate the value of amounts of money we have, we want to minimize that. So because we want to minimize this pair. The first priority is in the number of operations, and the second one is on the negative amounts of the remaining one. So I just see that if I want to go from this cell to this cell, I see that what is the cost, what is the distance between these two, and what is the number of steps that I have to do to reach there, I2 minus I1 plus J2 minus J1. And then I see that how many seconds I should stay here so that I can move along this path. How many steps I should stay here so that I can move along this path. Well, the point is that that value is gonna be my cost minus the money that I already have divided by this value, divided by P of I1 and J1. And this is only because of sale, because I want this value to be sale of this division. Because it should be something that I should increase this money such that it would be more than cost. So I say that it is gonna be cost minus the money that I have already plus P of I1 and J1 minus 1. This is only for calculating sale divided by P of I1 and J1. Okay. This is the minimum time to stay in this, the minimum time that I need to stay at this cell to move on to the next cell, to the next step. And then I can say that my new best, the best that this solution provides, is best of I1 and J1 plus need for staying at this cell plus D to move along this path. And the new remaining one will be rem of I1 and J1, what was remained before coming here, plus need, which is the minimum number of seconds that we will stay at this cell, times P of I1 and J1, minus this distance, because we gain this amount of value, but we will spend this much afterwards. So first we get this much, and then we will spend this much afterwards. And at the end, I see that if this new solution was better than the solution that I have already, then I will update my current solution. Otherwise, I do nothing. So this is how it works. And at the end, it's just enough to print best of n minus 1 and n minus 1. Does this make sense? If you have any questions about this problem F, tell me. I know that it has some delay. I will definitely inquire about that, and I will solve that for next streams. This might be really bothering. I will fix that for the next streams. So if you had any questions about this problem or any of the other problems, you may ask now. Otherwise, if you have any other type of questions, anything that you want to ask, you can ask that now. I will wait a little bit so that I can see your answers. So that you will see what I said and ask questions in the chat. Okay, seems like there are no other questions or comments. Right? Okay, guys, so it was so nice having you here in this live stream. Seems like there are no further questions. Uh, and don't forget to tell me if you want me to talk about any specific topic. If you want me to make video about any specific topic, I will try to do that for you as soon as possible. So I think I will see you in the next one.